Good morning, teachers and professors. My name is Hanzhou. Today, my presentation is about hydrogen energy monitoring platform application. The presentation will include the following parts: background, the goal of the study, related technology, platform structure, data analysis, the main conclusion, and finally the discussion. First is the background. Hydrogen is known as clean, efficient, and safe and sustainable second energy resource, and will become an important media for future energy revolution. Hydrogen has the potential to be used in various arrays, and for example, fuel cell can convert the hydrogen energy into electricity with water and heat as byproducts. And currently, big data technology has played an important role in improving business and innovation. Recently, in recent years in China, the government used big data analysis and data mining technology for battery inconsistency and fault diagnosis, driving behavior analysis, and charging behavior and charging infrastructure location guidance analysis. So therefore, it shows that big data technique can improve the safety for new energy and promote the development of new energy industry. Based on these backgrounds, our research group implement the big data technology to monitor and improve the safety of hydrogen energy industry. The platform includes the key points about data acquisition, data mining, and data sharing. In this project, we establish a full chain information monitoring system of hydrogen manufacturing, storage, transportation, fueling, and usage. And we realized data monitoring and statistical analysis of fuel cell vehicles include economic, reliability, and durability based on the modeled analysis method. And also we focus on study active safety protection methods for high pressure hydrogen pipeline leakage. And then we implement intelligent scheduling for the hydrogen chain for manufacturing, storage, transportation, and hydrogen fueling. And also, based on the platform collections, we establish evaluation criteria for the demonstration of hydrogen energy and fuel cell vehicles. To conclude, the key technologies in this platform includes platform architecture design, data access technology, and also the diagnosis and analysis algorithm. To achieve this key technology, we use some related frameworks. First one is as we can see in this figure, the streaming process of raw data is realized with Flink and Kafka. Firstly, the raw data is distributed to multiple Kafka topics, and then the multiple handlers for different requirements are developed to consume this data as consumers. And then the processing results are distributed to corresponding result on Kafka topics. We use Flink computing frameworks to process the real-time streaming data. And this project receives the execution program passed by the dispatcher through job managers. And the execution program includes the job graph, logical graph, flow graph, and all of its classic files, third-party class libraries, and so on. Then the job managers will convert the job graph into an execution graph and then apply for resources to the resource manager to perform the task. Once the resources are requested, the execution graph will be distributed to the corresponding task managers. And also this platform use Kafka as a message queue to transfer the calculation data to the database in real time and complete the distribution of information. Combined with the streaming process technology, we also use Spark technology to do the statistical analysis process of historical data. As you can see in this figure, first bench processing requirements from other processes are created and submitted to the Kafka task queue in form of tasks. And then task scheduling service obtains the task and submits the corresponding Spark bench processing algorithm to Spark cluster for the calculation according to the task description passed by the Kafka task queue. And then the algorithm module gets the historical data from HBase to complete statistical analysis or module calculation tasks, and then send the calculation results to HBase or Redis for storage. Based on these technologies, computing frameworks, we designed this platform structure. This monitoring platform is designed to process the full chain data of hydrogen energy. So the data flow of this platform will flow like we showed in this picture. First, real-time data is input from enterprise platform according to certain transmission standards. And then the data flows into the two-level real-time processing module, which includes fast processing module and streaming processing module. And the fast processing module is based on a C++ self-developed program, and streaming processing is based on the Flink framework. The results produced by these two processing modules will flow into data store service module. In data store module, statistical data, early warning data, and the module analysis results are stored into databases. Based on the stored information, offline bench processing can be performed for data backtracking and information mining. Both raw data and processed data will be can be accessed through the web interaction. And based on the historical data we collected on this platform, we do some research in the data analysis. For example, this service is about to count the online vehicles in real time. We designed this algorithm to count the real-time online vehicles. So we use two threads to maintain this service. During the initialization, existing information of vehicles in Redis database is read and synchronized to algorithm's cache layer, which use HashData as storage structure to realize fast indexing. And when the analysis algorithm is running, main thread will read data from Kafka message queue and pass data records into JSON object, and then transfers data to cache thread. The cache thread then compares the vehicle information with existing data in the cache layer. If there is difference, it is considered that the online status of some vehicles is changed. So the program adds the vehicle ID to the set corresponding to the current state, and the status change information are added to pipeline of Redis. The instructions in pipeline are executed in bench every 1 second. Since that maintain the high concurrency for the algorithm. After we achieve this algorithm, we do some test for the algorithm. The runtime of the algorithm is tested on a computer with i5 CPU and 4G RAM. The testing result is shown as the as the figure. We can see that the amount of data that the algorithm can process per second is about 1 million. And with higher CPU and RAM, we will get better results. Here comes the main conclusion. For this program, we developed the big data platform for hydrogen energy monitoring, and based on analysis of the big data component and stream processing technologies, and also the requirements of the information monitoring system, we designed the two-level streaming data processing architecture. And also we apply Flink, Kafka, Spark, and so on technology to realize the real-time and also the historical analysis of the system requirements. And in the future, as data will continues to rise, so we would consider how to prevent the data skew problems. And for specific services, we'll consider deploy multiple copies to achieve the load balancing. For example, the data access service and the data store service, which will access multiple data resources. And also for deeper development, we will consider to combine with the container management. So here is my presentation. That's all. Thanks for your time.